Let's do another example of analyzing a function. Now, some people will say what we're doing is graphing the function. Graphing is never the answer. Graphing is a tool that you can use to analyze a function and then analyze the model that that function is representing for you. And so I've picked out a function that has some plausibility. It has the kind of things that appear in functions, which is, well, so you could either say y or f of x, doesn't matter. As long as you're consistent about it. And what I have here is a function that's a sum of two things. Those happen to be fractions, and those happen to, one of them blows up at 1, one of them blows up at 3, and so wear protective equipment. What's important here to notice, and this sometimes gets lost in the subtleties, is that this second term is, we're saying it's twice as important because it's got a coefficient of 2. So there's some process going on that has double the importance of some other process going on, but we're adding the results together. Or you could have 5 times the influence or 12 times the influence, or even negative influence. We'll see some of that when we start to do some more explicit modeling. So this is a function. You're trapped between 1 and 3, more or less. We're going to look at the whole picture, but there's the deal. So how are we going to analyze this function? We've got a big tool for analyzing functions, and that's the mean value theorem. So if y prime is greater than 0, that means that y is increasing, and the flip side of that, there's the flip side, is if y prime is less than 0, that means that y is decreasing, and I'm abbreviating increasing and decreasing. This is the mean value theorem. And this is the biggest tool that we've got for analyzing functions. And nobody but me says this, but this is almost calculus right here as far as how we apply it to making models. Okay, so what we're going to have to do here to work with this function, everything to do with the mean value theorem needs to be factored because you need to know where whatever it is, the derivative or the second derivative or the ninth derivative is 0. And the only way to find out where something is 0 is to factor it. And so we're going to have to factor this expression that we're given for the function. And so that means we're going to add up the fractions. And I'm going to do it in the right way, which is to do the parentheses first. So I'm going to take the common denominator, multiply, which is the product of these two, put that on the bottom, fill that in later, do the parentheses first. And on top, I'm going to have 1 times something plus 2 times something. That's what happens for this term. You have to multiply top and bottom by x minus 3, so that's going to be multiplied by 1. For this term, you have to multiply top and bottom by x minus 1. And that's where the 2 comes from. So that's doing the parentheses first, and now I'll fill in all that stuff. So I've got x minus 3, and x minus 1, and x minus 3, and x minus 1. That's just a cut and paste operation. Don't try to do any algebra in your head. Don't try to do algebra in your head. Ugh. Okay, do the parentheses first. Now I have to multiply this out. And for expedience, I'm going to do it in my head. Well, I'm going to do it in the rehearsal sheet that I have sitting here. So on top, we've got x minus 3 plus 2x minus 2. And on the bottom, we've got x squared minus 4x plus 3. And so I've just done the algebra there on top and on the bottom separately. And now looking at what we've got left on top, I'm actually not going to write the bottom, and you'll see why in a second. But it looks like I've got 3x minus 5 on top, and then the bottom is blip, blip, blip. I'll just write something in Martian there. Okay, now I'm going to take the derivative of this and then find the sign of the derivative. We're going to find the sign of the derivative, and that's going to be the first thing that's going to make your life a lot easier, which is to say, I'm going to say over here, y prime is, well, the most important thing about y is that it's a fraction. So I have to use the quotient rule, which you've read about. The easy to memorize version of the quotient rule is low d high minus high D low, square the bottom. There you go. So I'm going to square the bottom. If I square the bottom stays positive. There are a couple of places where it's 0, but the bottom stays positive. And that means that the bottom cannot change the sign of the derivative. It's positive. And that's the kind of thing that you have to do. You don't have to know what the bottom is. You have to know it's squared. So that's what I've done. I've said the bottom squared. Good, okay. And then we're going to have low, D high. I probably didn't leave enough room. Minus high, D low. So the low function is x squared minus 4x. Oh, I'm sorry. Let me show you the parentheses. The x function is, the bottom function, the low function, x squared minus 4x plus 3 times the derivative of the top function, we'll get to that in a second, minus the high function times the derivative of the low function, which is still, the low function is still x squared minus 4x plus 3, and the high function is 3x minus 5. And so there it is. The low function is in pink and the high function is in blue. Don't do the derivatives in your head. Don't do the derivatives in your head. Do the parentheses first. Okay. Well, now we do actually have to do them. So I'm going to leave the bottom alone. It's squared. That's all I care about, is that the bottom is squared. And on top, the derivative of the high function is 3. So I'm just going to multiply everything by 3. 3x squared minus 12x plus 9. And then I'm going to subtract off something, and that is going to be a product, 3x minus 5. Take your time in algebra, 2x minus 4. Don't skip these steps. Don't skip these steps. And then continuing on, we've got the bottom squared, and now we're going to have 3x squared minus 12x plus 9. The thing in the parentheses on top, that second thing, is 6x squared minus 10 minus 22x plus 20. So now when I subtract that off, I've got the parentheses there. So I've just written this up here as a reminder. I'm going to subtract off each of these terms and make sure I do it correctly. So we have a minus 6x squared, a plus 22x, and then a minus 20. And what that works out to be is, the bottom is still squared, we're going to have minus 3x squared plus 10x minus 11. Woo-hoo! So there's Math 1108 algebra, basically. And now things get really exciting because, okay, the bottom of this derivative is squared. That means the bottom doesn't change the sign. Forget about it. The top is the thing that controls the sign. That's a downward-facing parabola. So when we find the roots of that top, not the whole thing, just the top, then we'll be able to find out where the derivative changes sign. And so let's do that here. I'm going to draw a downward-facing parabola. And it's downward-facing because we've got minus 3x squared. And now I'm just going to throw this into the quadratic formula. So that is a big old nasty fraction. The bottom is minus 2 times the x squared coefficient, so the bottom is minus 6. And then we have minus 10 plus or minus a big square root. And what goes in the square root is what's commonly called b squared minus 4ac. So that's 100 minus, there are two minus signs up there, plus the minus from the quadratic formula. 3 times 4 times 11. Bingo. Okay. So what we're going to have to do here is look at this quadratic formula thing. And it's not that bad. It looks bad, but it's not that bad because what's inside the square root is negative. So this has no real roots. You don't have to do out the whole quadratic formula. You don't have to find the square roots. You don't have to complain to the gods of mathematics that you have to do such trivial, dirty work, because you don't have to. Inside the square root is negative. 12 times 11 is 132. You subtract that from 100, and it's negative. That's all that matters, is that it's negative, and so there are no roots. And that means that the derivative is always negative. I'll just draw y equals 0 here. And so that's our situation. The derivative, the top is always negative, the bottom's always positive, so the whole thing is always negative. So y prime is less than 0 always. And one other thing that we can throw in here, we'll have to come up to here, is notice that there's a horizontal asymptote of 3. So I'll throw that up in here. Horizontal asymptote y equals 3. So that's now going to tell us the graph of this function. I'm going to draw the asymptotes, y equals 3, x equals 1, x equals 3. The origin does not go at the center of the picture. The center of the picture is what goes at the center of the picture. And now I'm going to take advantage of knowing the asymptotes and knowing that the function is always decreasing, and that's going to give us a situation like this, always decreasing, and then a situation like this, always decreasing, and finally a situation like this, always decreasing. So there we go. So that tells us what's going on. Usually in a model it would just be part of this piece, but there's the deal. So decreasing functions with asymptotes, you go right up against the asymptote and just slide on down or slide on up. Or with horizontal asymptotes, increasing, you just go right with the asymptote. So there's the deal. This one's a little more subtle, but I'll put this page up on Moodle and enjoy.